Greetings, math fans. All right, so what we're going to do today, this is day 8, and we're going to talk about finding a formula or equation for the extended function that is continuous at the indicated point. Okay, so basically we're going to have a function that's discontinuous at a point, and we're going to create a function that will make it continuous at that point. All right, so if I give you f of x is equal to x squared plus x minus 6 over x squared minus x minus 12. All right. Basically, if I would just to factor this to see what's going on here, I'm going to get x plus 3, x minus 2 on top, and the denominator I'm going to get x plus 3, x minus 4. All right, so you can see, first of all, where is it? Here, let me give you an indicated. I need to give you an indicated point. So at x equals -3, that I need this function to be continuous at that point. Okay. Well, how do I make this function continuous at this point? Once you do factor it, and you notice, really, what do we have here? We have a hole. So do you guys agree that if I just write a function like this, f of x equals x minus 2 over x minus 4, well, sure enough, it's not going to be continuous at 4, right? It's going to be an infinite discontinuity, which is, of course, non-removable. But at x equals -3, if I write this function, it's going to look exactly the same as we've actually done before in the graphing calculator. If you'd graph both these functions, the original and this new function here, it's going to look the same, except now this function, this new guy right here, is not going to have the hole at x equals -3. Okay, it's actually going to be continuous to that function. So my extended function is going to be basically I can write this g of x equals x minus 2 over x minus 4. Okay, which is exactly what this function is here. But this is the function that I'm looking for. That is continuous at my indicated point. Okay, so that's actually pretty easy. If I give you guys another example, f of x equals cosine of x minus 1 over x, and the indicated point is x equals 0. Well, you know what the limit is. The limit as x approaches 0 of cosine of x minus 1 over x is equal to 0, right? But that's a limit. So I'm looking at one side and the other side, but if I actually said what is f of that value, what is f of 0, you would say it's undefined there. So what I need to do is I actually need to create a piecewise function. Okay, and I need to make it where, so here's g of x is my new function. Well, don't you guys agree it's really continuous at every value except for 0. So for all values except for 0, it's continuous. Okay, it's just when you get to 0, right, f of 0, it's not continuous. All right, and again, to make it continuous at x equals 0, what does this is probably the toughest part here, which actually is not that difficult. What does that value have to be? Well, remember, the limit, and I said this already, limit as x approaches 0, cosine of x minus 1 over x is equal to 0. So that means it's getting closer and closer and closer to 0, but it's not going to get there. So what I'm going to do is I'm just in this piecewise function, I'm just going to make it 0 at that point. So now it's going to actually be filled in at that location. It's going to be filled in with the value of 0. And this function, if you would graph it now, this would be a continuous function. All by itself is not continuous because not continuous at x equals 0. All right, so that's basically what you're doing. What you're doing to create a piece or to create a a continuous function. So the first one, I just kind of rewrote it and created a function so I wouldn't have a hole in there anymore. And this function, I created a piecewise function. All right. So I kind of plugged in that hole. All right. So that's the first part of finding a formula. Next type of example, it's going to say find a value for A that makes the following function continuous. So here's your function, f of x equals, it's a piecewise function, x squared minus 5x plus 2 when x is less than 2, and 3ax plus 4 when x is greater than or equal to 2. Okay? So if it's continuous, what are some of the things that has to be true, right? Well, isn't it especially at this point right here, if it's continuous, because you definitely know that x squared minus 5x plus 2, it's a quadratic, it's a continuous function, and 3ax plus 4, that's a linear function, that's continuous, okay? But the deal is they have to actually meet up at x equals 2. So just a little note here, remember, the limit as x approaches 2 from the negative side of x squared minus 5x plus 2, okay, because that's when it is less than 2, has to be equal to the limit as x approaches 2 from the positive side of 3ax plus 4. Okay, that has to be true. So I can just do a direct substitution here because, again, I'm looking for at that value. And if I do that, I would say 2 squared minus 5 times 2 plus 2 equals 3 times 2a plus 4. So I get 4 minus 10 plus 2 equals 6a plus 4. So that gives me 4 minus 10, negative 6, plus 4, plus 2 is negative 4, equals 6a plus 4. So 6a, subtract 4 from both sides, equals negative 8. So a equals negative 4/3. And if you made that function, a is equal to negative 4/3, it would be a continuous function. Okay? Pretty short lesson today. But that's pretty much it. Finding, again, a formula for an extended function and actually finding a value for a that makes a function continuous. All right? That's it, my fans. Have a great day. Adios. Goodbye.